August 11, 3:30. There's something about the submer here, solar pump, that is bothering me. In April, I powered up with the generator, and the generator was having a hard time energizing the solar pump submersible, and has to do with the power factor. The generator itself is 15 kilovolt VA, 15,000 VA, and this thing is only 3,000 watts. So I am puzzled as to why the generator is unable to energize a 3,000 watt submersible, being that the generator itself is 15 kVA. And the engine that I use to power up the generator is 9 horsepower. So that should be more than enough to energize the generator to power up the submersible. So I'm going to do some tests using the solar connector. So I'm just gonna do this and see what's going on with it. First, I'm gonna turn on the submersible. The reading at the panel is 193 volt. However, it's actually out of calibration. That 193, just add 10 volts to it, so it's 203 volt AC going into the control box. So let's see here. The RPM is 3500 RPM. Current draw is 10 amps, and the wattage is 2800. So that's around 300. Give or take 200. That's let's just call it almost 3000 watt. So the 3-inch pipe, the outflow is almost full. Let's just call it full. So with almost 3000 watt submersible, that is the output. Someday soon I'm going to actually measure the flow rate of this thing so that I have a much better understanding of this submersible. So I'm going to simulate a solar panel going into the control box. The circuit board I bought from Lazada shows the capacitor. Capacitor is 4, so this one is 4000 mics. So the reading is 450 volt DC, 1000 mics. So there's 4 of them in parallel, so it's 4,000 mics. So and I have the bridge, so I'm gonna power up the control box using this get up or setup. I want to control the system and test something else. Like I said, the power factor is affecting the generator, and I just want to understand why. And the only way to do this is to actually do this setup. So I connected the AC power to the what do you call it, bridge, and then the AC is rectified. So the voltage at the rectified with this filtered is 300 volts. If the voltage is 240 volts, then we would be reading 312 volt DC. So at this point, I don't know what it is. So I'm just gonna turn on the power and see what happens. It shouldn't, in theory, blow up. However, if it does, it does. So let's do this. So it's on. And The power here, it's reading the solar to be 288. So it's using MPTT. It looks at the voltage and then energize the solar pump appropriately. So at this point, if the, for example, I'm actually simulating a solar panel. So the solar panel would be loaded like this, 267 volt DC, and the RPM at 3600, and it's drawing 11 amps. All of these are in DC. And then actually I'm quite surprised. It's at 3000 RPM. I mean 3000 watts. It's actually at full power. So seeing that it actually does work, I'm going to do some more experiment. So with this, at 3000 watts, the outflow is a little bit cooler. Once I have a method to measure the outflow, I should have a much better understanding of how this is working out. Now in theory, the generator should be able to handle this without having to worry, or without having to use the power factor correction in the power being generated by the generator. So that's the reason why I needed to figure out what the hey with this. So let's see here. So 266, the RPM is at 3700. We just call it at 3. See, with this, in theory it should be like 4000 RPM. However, see, this is at max 3000 watt. So I can't go any higher. Maybe I could. Let's see, maybe could I go higher? Okay, set. Oh, I can't because it does a P0. So it can't do it for at 4000 watt. I mean at 4000 RPM. It won't let it. Okay, so it needs to have a power reset. So once it has this steady P0, it won't come on. So I have to unplug the power. Let me just do this. Or maybe there's a timeout. So I'm just gonna do a power hard reset. It went into another error, P0.1. So I'm not sure what that is. I lost the manual. So I disconnected the module, and I just heard the relay do something silly. The control box, it gets, maybe it's because it's exposed to the sun. It really needs to be in a shade. So I'm gonna put it inside as soon as I'm done with my experiment. Come on. And because there's large capacitor inside, it takes a while for the thing to discharge and turn off. So I'm just gonna have to wait. Okay, the residual voltage is done. So I plug back the capacitor and I'm gonna power up again. So I'm just gonna, what I'm going to do later is place the control box here and the other control system. That way it's out of the sun and out of the rain. So it will be in theory protected from the environment. Let's see. Just thinking about the capacitor. I don't want to have it exposed in for people to get killed or shocked. Now the reason why I'm doing this is later on I'm going to put a switch. It will switch the AC and then solar, or later probably a way to have the two working together in parallel, solar and AC. That way there's always going to be power to the system. When it's cloudy, it'll switch to AC power, or if it's in parallel, just take whatever it can get. So we'll see. I'm just gonna power it up. So it's going through its setup. It's 294 as the submersible pump is on active. It loads the AC, and then it's on. I can hear it's at 3600 RPM. I think that's max for this 3000 watt. It's at 3600 RPM. That's max. The system is self-programmable or automatic. If I go to I think if the voltage is around 400 volts, it would go to 4000 RPM. However, because of the droop 272, I think it's programmed to just idle at 360 RPM. The wattage though is at 3000 watts, so I think that's all right. So I'm just going to measure the voltage at the capacitor and see what it is. So I'm measuring the voltage at the capacitor, and it's 278, and the meter is 272, so there is a 6 volts difference in this. Now if it's not heavily loaded, it would be 312. So let me just do some calculation. Actually, what am I going to do? First I'm going to measure the AC and then look at the RMS of this thing. The voltage is 235 without load. So I'm gonna check the control box. It's acting up. It's saying something silly. It's right now it says PL, which is power low. Okay, I put it back to AC again. So it's 202. That's just that this is actually I need to measure that instead of guessing. So I'm just gonna quickly measure the input voltage. Yeah, the voltage on this side of the switch is 228 volts AC, and I'm just gonna check the upper side because sometimes there's a voltage drop. Yeah, same. There's no voltage drop across the switch. So yeah, I have to check my what those error codes are. Still, even at that RPM, it's actually a lot of water. Yeah, it's still sandy. Actually, water's not bad. Clean. It's not smelly. Yeah, it's look like it's gonna rain tonight. 12th August, around 10:30. This system was glitching yesterday. I wasn't too happy. So I added another 4 capacitors. So now they would be each one is 1,000. So each one would be well, this whole thing would be 8,000 mics. That should stop the glitching in theory. So I'm just gonna test it now. So it's on, and the RPM, well, no, the voltage is at 286, and that would droop. So it's active, 266 volts. It's actually off by 6 volts. So 266 plus 6, it would be 272 volts DC here. And then RPM is 3, let's just say 3600, 11.2 amps. It is a 3000 watt max. So this is what it's rated for. So with this, and it's actually using MPTT, so it's looking at the voltage, adjusting the RPM according to voltage, and it also look at the amps. So it says, oh, I can set it up at 3.5 or 3.600 RPM, 11 amps. So it's actually running at max. Now I'm just let it running for a few minutes, because yesterday, after 1 or 2 minutes, it started to glitch. So I wanted to see what's going on in like 5-10 minutes. Next go round, I really don't have a way to measure it right now. I've been so busy. So I'm going to measure it another way and see what's the flow rate. The 3-inch pipe is actually full. So that should give me a fairly good estimate later when I started to check for flow rate. So I'm gonna measure the voltage going into the control box. So it's 271 volt DC, and I'm going to check the AC source. So the AC source here, it's 220 volt AC, and the same thing on the switch side. It's always good to measure this side and that side. Sometimes this is adding resistance to the load, so you want to make sure, or one should make sure that the switch is not adding resistance or impedance to the load. So that's really important. So yesterday I only had 4 capacitors, and it was glitching. When it glitches like that, it disturbs the quality of the power going into the control box. Because it's using MPTT, so if it's glitching, the controller can't figure out what to do next, so it just throws out an error code. I don't know what this error code is, just that I know that it wasn't a good clean power. So with 8 capacitors, it's filter out the pulsating DC to coming out of the bridge rectifier. So it moves it out, and then the MPTT will do its job properly so it won't glitch. So that's what I'm going to, well, at least that's how I figured it out to be the root cause of the error codes. It's been running for 3 minutes, so it looks like it won't glitch. Later on I'll make this a permanent fixture, but right now I'm just gonna install the control box using the AC and then come back later to install this once I have it in proper housings and no one can get hurt from the exposed conductors. Thanks for watching.